So, something like that then. So you should be able to see this online also. Yesterday's lecture is, the recordings are rendered and can be found on YouTube. I will post them under each and every lecture as we go along. But also I created a playlist on YouTube, so you can just check that out if you prefer that format, and just get the whole list of lectures in one link. So this, I posted this link here, so you should be able to check it out. That being said, also yesterday we talked about the course introduction, and we talked a little about when to do analysis and design, why we do analysis and design, why we use object orientation, and a little short bit about the UML, what it is. And we did not finish the dice game, so this is our starting point for the day. Just to get a little bit of a feeling for what we will be doing in the course, and looking a little bit at these diagrams and models that we will be producing. So, as I said yesterday, we need to have some kind of starting point, and often the starting point is requirements in different forms and kinds. And I've just written down a simple requirement for this little dice game example. And it just says, the requirement 1, play dice game. The dice are rolled and the result is presented. If the sum is 7, the player wins. Quite a little neat program, maybe. So I will just move that up there. So the first step in the process is then to create some kind of analysis. And the type of analysis we will be doing is domain modeling. And domain modeling is about finding key concepts in the requirements and in the problem domain, and deciding how they relate to each other to support the requirements, to facilitate understanding of the requirements and finding problems in the requirements. So just on the top of your heads, can you find any key concepts just using this small requirement? Any idea of what a key concept could be here? Dice being rolled. So a key concept could be dice. So yes, let's just put it here, dice. Fine. And they are being rolled. Who rolls the dice? The player. So we probably have a player also. Do we have anything else? Score, or at least some kind of a sum or result, maybe? Let's call it score. Yeah, you also had result here. The result, score, sum. We can debate the names, but I just selected score because that was first. So I think I have result in my old notes. Anything else? We have dice, we have player, we have a score. Any other concept here that you think is important? The exception? Yeah, some kind of rule. So we have some kind of rule. Anything else? Output? Yeah, probably. But that is kind of like the values of the dice, maybe. So each dice are rolled, they get a value, and this is what the player can see. We have some interesting stuff here on the chat. A question: 1 dice or 2? And well, obviously not 1 is the. I'm assuming it's 1. How are you going to get 7 out of 1? This is actually something that is quite interesting, because we don't know. We don't know the number of sides on the dice. We can assume that it's 6, but assumptions are probably not that good to make. Could be a dice with 10 sides, 20 sides. Could be 2 dices with 4 sides, or something like that. So this is very interesting, that using analysis and domain modeling, we found something that is missing from the requirements. And assumptions is the mother of all fuck-ups, so don't assume. You need to go and ask. You can't sit there and program and assume that, oh, it's a 6-sided dice, and it's 2 of them. But we can decide. In this case, we can decide. So we decide we have 2 dices. And we decide that the value can be one through 6. Yeah, and we also have the problem the dice are going to be rolled once. Maybe that is something you could say is there, but absolutely, if we are unsure, we should ask, of course, someone who is the dice game expert. So you can see here, by doing this visual modeling and thinking about the requirement, analyzing the requirement, we find problems in the requirement. Exactly, we need some kind of dice specification. So we decided now that we have 2 dices that we roll, and they can have a value, and this value is between 1 and 6. So we know that we have 6-sided dices, and there are 2 of them. One thing that is missing, I think at least, is some kind of dice game concept. So we could just have this. And this is actually what the player plays. And the rules computes the score, and the dice game has rules, and the player, let's just say use the rules from now. This could be a somewhat overworked domain model for this small requirement, but at least we could find some central concepts here. Dice, absolutely. Player, we have rules and score, and I think we also have the dice game. And if you kind of like look at these, you can see that we have a type of class of words that we call nouns, substantiv in Swedish, as the central concepts. So we could find the word dice here, dice game, player, we had sum or result. Rules were not really there as a word, but by reading this we could realize that there is some kind of rules. And also if we think about this as a physical product, a box, the dice game, you open it up, you probably have this little paper with the rules on them that the player used to understand the game and play the game. It has dice contained in it, and so on and so forth. And if we check out these little guys here, you can see that they are verbs. Now, I'm not saying that this is always the case and this is just what you do, but it can give you at least a starting point. And what we have actually created here is a class, and we have attributes, and we have associations, and we have association names. So this is basically the notation of the domain model. The largest part of notation you will be doing is finding these classes. And we call these classes conceptual clauses because they are used in domain modeling, and they are to be connected to the requirements, to support the requirements. We will be doing also design classes. The notation will be exactly the same, but it is good if you can separate the two so you know when you're doing design and you know when you're doing analysis or domain modeling. Yes, this is, as pointed out, quite a large design domain model for this small of a problem, and doing some kind of over-analysis of things is at best a waste of time. At worst, it just confuses the stuff. So, but it serves as a starting example at least. So, when we have done the design, domain model, we can move on to, and using this model we found problems in the requirements that we further specified. So that was a good thing. So we move on to the design model. We haven't been talking so much about what we do here, but the focus of the domain model is to find problems in the requirement, to understand the requirements, to find these central concepts to use to understand the problem. It has nothing to do at all with software. So it's completely free. And you should take this opportunity to not think about software and how to actually solve things using software. But this is the focus of the design model, to break the problem up in good chunks so that we can devise and implement a software solution for this requirement. In the book, we have two kind of diagrams mainly for this. We have a dynamic side of things that shows how the program actually executes, and we have a static point of view that shows, okay, these are the classes that we have, and they are related to each other in this way for this system to work. In the book, he likes to start with a dynamic view. Personally, I almost never do that. You could try both ways. It's up to you, but let's do it by the book for this small example. So we will be doing a sequence diagram that shows the sequence of calls in the system to implement this requirement. And we will focus on not on the user interface kinds of stuff. So this little dude here that I call player represents the user interface actually. So, well, the first thing that we can see, can I do this? That we can see happening in the requirements is that we want to play the dice game. This is like the starting point, play dice game. I'm the player, I want to play the dice game. So, the player needs to send a message to something in the system. And looking at the domain, well, maybe a good name for this message should be play, so that we know that what we are doing. I won't call it do stuff or something like this, because that won't be a good name. So, who does the player tell that he wants to play? Well, he tells it to the dice game. We can see in our domain model, we have a concept called dice game. We have a relation between player and dice game, and this one is even called place. So this could be a good starting point then. So, what happens when we play? The dice are rolled, so we need to roll some dice. Okay, who should roll the dice? Well, the player could roll the dice. Maybe this is not the perfect way to do it in the software, but rather maybe let the dice game roll the dice, because maybe the dice game contains the die. So let's do that. And we should have two dices. So the dice game asks the first dice to roll, and the second one roll. So what do we need to do next? We have rolled the dice, and we need to know the result here, and we need to compute the sum, and we need to tell if the player has won or not. So to compute the sum, we need to get the value from the first dice. and the second dice. And then we can return something here. Win, lose. I haven't looked at the chat lately, so yeah. So this is the dynamic side of things, that this design implements the requirement. We have made some assumptions here that are maybe not that easy to just accept. For example, that the dice somehow rolls the dice games. That's not how it happens in reality. So, but this could be something that we change in the design, because the design is about software. So here we decide. In the domain model, the reality decides, the requirements decides how it should be. In the design model, software decides. So that was the dynamic part. Sequence diagram. We can see some stuff here, and these are actually objects. This dice game here is an anonymous object. It has no name right now, but it's an instance of the dice game class. Because this shows execution of code, the stuff up here are always objects. Classes do not exist when the system runs. Objects are created from classes, methods are called on these objects, and stuff happens. And here we have a named object, the dice, MD1, and we have a second object that is named MD2. Really good names. And here we just have method calls or function calls or member calls, or what you call them in your favorite programming language. And the next step is to take this diagram of the dynamic side of things and transform it into a static view, a class diagram, so that we can see the classes that exist and how they are related. And we can see that we have two classes, dice game and dice. You have the value, you have the role, and get value. And here we have play. This we all can see from here. Play is called on a dice game object. Roll is called on dice objects. Get value is called on dice objects. So these classes need to have these operations in them. We could also add the value based on the domain model. We need that this needs to exist, because in roll we need to set it to something random, and we need to return it in get value. And also we need to decide on the relation between the dice game and the dice, because an object of this class needs to call objects of dice called MD1 and MD2. And actually I have just decided that these are put together using associations. that are called MD1 and MD2. So this is the somewhat simple design that we have. And we can also see here that the domain model, well, it was probably overkill. The rule is so simple, and this score and stuff like that, that's so simple. So what has actually survived is dice game and dice, maybe player. But player not really. So let's move on to implementation. So maybe we have some interesting questions here. Yeah, we have a debate about die and dice. Actually, I tried using the word die in one lecture, but when we came to implementation, it was a reserved word, so that was not a good class name. That's why I use dice. You can always run into these kind of problems. The M in MD1 and MD2 stands for that's just a convention from my side of point. I like to name these kinds of variables member. M is for member, so that when I implement later, I know what kind of variable I'm juggling. But that is just completely for my own purposes. So let's move on to implementation. Should I up the font even more for you guys online? Anyway, I'm using a small IDE called Dr. Java here. I've not really used it that much, so let's hope it works out. But you can compile and run and do stuff here. You don't need to use it if you don't want to. If I run this small test program, this is the starting point of a Java application in C#. Well, it's quite similar. We have this static void main, some arguments, and this time I just print hello dice game world. So what we need to do here is create a new file, a new class. Let's create the dice game. Let's just add the play operation. And let's just return true for now. Save it, let's compile, let's run. So, okay. Let's create a object of this type then. So, of course, we're a winner because we just returned true from dice game. If we return false, we get the sorry. So, good. We need the dice also, of course. We can just check out our design. You know that we need a dice class, and that is our next point to do. Let's see if I find my remote desktop once more. So, new file. We need that the dice needs a value. A roll operation. That sets the value to something. Something like that, maybe. So in the dice game, we should have two variables of this type inside the dice game, named MD1 and MD2. We need to add the constructor and create these objects. And here we should do something with them. First MD1 roll, MD2 roll, and we should return the sum here, MD1, or check the sum of the values rather. Get value something like that. Let's compile. Int let's run. We should lose because we always return 1, and we need some random number here. Math random, I think 17, 17, 17. So we just create a random number, and I think math random is between 0 and 1.1. So we need to get a larger value. So I just multiply it with some constant, and something like that, I think. Oh, I won. I lost. I lost. I lost. I lost. I lost. I think you can also do this. Ah, I won. So, okay, this revolutionary, fun, and challenging game of throwing dice is now finished. And of course, we should do some more testing. I bet this random implementation is not that really good, especially if you want really good random values. It's more complicated than this. You can look that up. It's actually quite hard to get good random number values in a computer. So, here we could actually see that looking at the dice game, the play looks exactly as the sequence diagram. I call roll on the first die, I call roll on the second dice, I call get value on the first dice, I call get value on the second dice, I do this rule computation here, use the sum, check the rules, very simple in this case. The dice game, well, it just contains the roll and the get value. There are, of course, other ways to do this. You could have designed the dice game to contain a list of dices or an array or something like that. But we opted for quite an easy little implementation here. So, this is kind of like the whole chain. This is what we will be doing. We will be doing analysis. We will use the analysis to get inspiration for our design. When designing, we look at the analysis and the requirements. We divide the problem up in using certain principles and patterns and stuff like that that we're going to learn. And then we implement this design, and it should be quite straightforward, depending on how much detail we put in the design. And also vice versa. If we find a problem in our code, we can make a refactoring of the code, and then we can make an update of the design. So we can go both ways. Based on our initial analysis, wouldn't we need a player class to introduce multiple players in a dice game? Probably yes. However, the requirements do not really say that we are supposed to save any scores or have any multiple players and stuff like that. And also, this is just a simple example. But I could see a player concept and a player class being added to this system if we have requirements like that. And this is, well, maybe not the most fun game, especially if you're not multiple players. So I can definitely see a player class being added here as we go along, maybe. So, good. I will be adding this code to the GitHub repository as soon as the lecture is over. So you can take a look at it there and download it. It should be quite similar to the other examples that we have done last year and stuff like that. If you have something to contribute, please do. I know this, especially the role operation is quite different in C#, for example. So you can take a look at that if you're into this. But this is kind of like an implementation detail. This was not something that we decided in the design. So there is always a balance to be struck between how much detail should you put in the design and how much should you leave up to deciding when doing implementation. So that is something that we will also look into a little bit further. So, all right, I think I will take a look at the quick look at the slides for domain modeling. So these are two, you can download these also on the course homepage, just as I did right now. So, as I said before, the domain model is a visual guide over a specific problem area. It contains important concepts and relations, just as we did in the dice game. We found the important concepts, we call these conceptual clauses, and we found relations and named these also. And this model is good for communication and understanding between stakeholders in the project. And what is especially good about the domain model is that end users should be able to understand it. The notation is really not that complex. You use the words from the requirements and from the domain. So at least some kind of test of a domain model is to take it to the end users or domain experts and ask them if it makes sense. The design model, on the other side, is quite software specific. So there you have another focus on the model, and probably a domain expert will not understand it. And we could use this model to find problems. We found that stuff was not really that specified in the requirement that we had, and this is common. We can find improvements. Maybe we can find opportunities to actually improve the processes and businesses of our customer by looking at a domain model. Well, we could do things like this instead. So even if we have requirements that say we should do things in this way, using the domain model, we could find better ways to do things. And we use the UML class diagram notation, or a subset of it, during domain modeling. So we have these boxes with a name in it, so that's a class. We have the line between the boxes, that's associations. So I think this is the final slide before we take a break. So the relationship between requirements and domain model is that the requirements delimit what we should do during our analysis. We should not do the whole world in our analysis, but we should restrict ourselves to the requirements that we have. And these could even be more restricted to the requirements that we are supposed to focus on during this part of the project. If we are working iteratively, we will probably just work with a subset of the requirements during this specific iteration, and this is what we should do our domain model for then. So we should not go overboard. Possibly we did this in the example that we did. And in turn, the domain model finds problem in the requirements. So there is a relationship from requirements to analysis and from analysis to requirements. And they are meant to complement each other, not be exact duplicates. Some things are better stated in requirements. And typically, dynamic stuff is better to show in the requirements, like activities, who does what, behavior, rules, actors, and dynamics. So this is dynamic side of things. Describing a rule in a domain model is often quite hard. We added the rule concept, but we did not actually describe what the rule said in the domain model. This is better to show in the requirements. So it's not meant that the analysis should be a carbon copy of the requirements. Rather, it's the requirements, but from a different perspective. And this perspective is to take a look at the chunks of information that are needed to be able to perform the requirements. The relations between these chunks of information, these classes. And as I said, this is supposed to support the requirements, to show the requirements from this point of view. You probably have a lot of requirements, and there is a good chance that the same concepts in the requirements come up over and over. And it can be really hard to know just by looking at one requirement what this concept is all about. So then you can take a look at the main model and see that, oh yeah, students apply for courses. But the requirements in itself maybe was about students getting grades or something like that, or a student has a schedule or something. So by using the domain model, you can get the larger, bigger picture. Looking at the requirements, you get the nitty-gritty details. So, and this side of things is more of a static point of view, and displaying dynamic information is hard in a domain model. So, I think it's time for a break, and we will continue with how to do some rules of thumb on how to do a good domain model. And this is what you will be doing also in the workshop next week, so it's good to take a look at that. All right, 15 minutes of a break then.